Greetings, my fellow geothermal students. Here we go again. Jonathan Bow, your instructor here, and today we're looking at some really cool stuff. Nanotechnology in association with geothermal. So, batten down the hatches, kick back, and check out this carbon 60 fullerenes. Yeah, here we go. I like that guy, Dr. Jonathan Hare. Check this guy out.
In 1985, a new form of carbon was discovered called C60, or Buckminster fullerene, and it's got exactly the same shape as a football. We're going to make a molecular model of this in a second, but before we do that we need to explore the
for those of you that don't know, that's a soccer ball here in the United States, but it's a football in England.
Shape of a football a bit more. Now if you look at a football, you can see it's made of pentagon patches, which are 1, 2, 3, 4, 5, we've got 5 sides. And we also got hexagon patches, 1, 2, 3, 4, 5, 6. Now there are 12 pentagons on the football, and each pentagon's got 5 edges and 5 corners. Now it's not obvious, but actually if you spend some time looking at football, you'll see that there's no corners that aren't actually in a pentagon. So if you count up the number of corners in the pentagon, that's 5, times it by 12, the number of pentagons, we've got 12 times 5, which is 60. So it's actually the number of corners in a football is 60. So if you put an atom at each of the corners on the structure of a football, you'll get the molecular structure for C60, which is why it's called C60. So our next job then is to use our molecular kit and actually make the model. So this is the pack that you've got.
And what we're going to find is that carbon stabilizes in the C60 form.
In it there are some little black atoms that you can see here, and these have 3 legs on it. And on these black atoms you put the straws, and we've got some red straws here which we break off, and we can get a single straw from that. And we've also got some white straws. Again, we break these up and get the single straws out. And we use the black ones, we join them together with the red straws, and we're going to make a pentagon, because if you remember the football's got 12 pentagons. So we join up 5 straws with 5 black atoms, and the straws will want to make a hexagon, so you just bend them to form a pentagon, and there you've got a pentagon. 1, 2, 3, 4, 5 sides and 5 black atoms. So we need to make 12 of those to make our molecular model. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we take our pentagon and we add one of our white straws. So we're adding just one bond and then another one. So we've used up all the red ones now, and actually we've used up all the black atoms. So now all we simply need to do is to start joining the pentagons together using the white straws. So we're sort of making a little man like this. And then what we can do is we can start joining these up, these up, these up, these and these. And this is the nice bit, because now as we join these up, what looks like it's going to be pretty flat and uninteresting starts to curve up. You can see that the thing's coming off the table.
What he's not mentioning is that the white bonds are slightly longer than the red bonds.
And we're going from a flat sheet to what looks like half a bowl. So you can see you've got something that's bowl-shaped now. So we do the same, we put that aside, and we put another one down. And we can do the same. Now there's many ways that you can make a C60. I'm going to make two halves and join them together. But you don't have to do it this way. And you've got another bowl. So we've got two halves which can join together to make the football. Okay, now all I need to do is fit some bonds, the white straws, onto the free legs of one half, like this. You'll see that in the kit there's a few extra bits, and then I can start to join these two together. And you're just going to make sure that you join them into the right places. So you want to join them up so that you get a hexagon here, and then you simply zip it up. And there you are, you've got your buckyball. Really, if you see here, what we need to do is join this together. And that's how the hexagons form. But what can happen if you're not careful is you can try and join another pentagon in, a bit like this. And that's obviously wrong, because if you count up, it's got 1, 2, 3, 4, 5, 6, 7, 8 sides. So that's an octagon. So that's not right. So what you need to do, it's very simple. You've just got to remember to always join them across to make a hexagon, not an octagon. So this is the completed model. It's got 12 red pentagons, and the hexagons come about just by putting the pentagons in the right place. We've got 60 black atoms, so this is a molecule, or model of the molecule of C60. The real thing is very, very tiny, so it's about a nanometer across. So that's a billionth of a meter in diameter. And it was named after an architect called Richard Buckminster Fuller. So sometimes it's called C60, sometimes it's called Buckminster Fullerene, sometimes it's called a buckyball for short. So this is a model of a buckyball.
Yeah, alright guys. Really good stuff. Geodesic projections. Very integritous, strong, circular. It has.
Shungite is a recently discovered new mineral of carbon, much like diamond or charcoal or jet, that was discovered in Koralia, Russia. It is a black stone that is often carved into spheres and pyramids. There's an array of different shapes that you can get from shungite. It's kind of a softer mineral, so it can be easily carved, and it holds a neat matte luster type of finish to it. It's used in pendants, spheres, polished cabochons, all different things. It has a unique mineralogical history in that it's been historically identified in Russia as having healing effects. There was a mine there, a big strewn field, and there was Russian soldiers who camped along the field and drank the water, and they attribute its healing effects to a molecule in it called fullerenes, or Buckminster fullerenes, which is a geodesic type of substance that's a carbon molecule that has a unique property of being a strong antioxidant and a carrier of oxygen in the body, kind of like carbon-60 and things like that. Shungite can be purchased in many different forms, from loose rocks to small discs to place on the back of your cell phone to protect against harmful EMF radiation. You can also take the loose rocks and add them to a jar of water, and it will purify the water and give it like life-giving health effects. So it's a pretty neat stone. Check it out at www.bigquartz.com.
Yeah. Shungite.
You may know carbon as the lead in your pencil, or the fuel in your outdoor grill, or even the diamond in your engagement ring. Now, many physicists are testing the stunning possibilities of a new form of carbon known as buckyballs.
If you could make a cable out of bucky fibers, even a very thin cable could support objects of tremendous weight. A 1-inch square cable would have the strength to hold up 30 million pounds.
Scientists at Rice University discovered the new carbon molecule in 1985, a shape that resembles Buckminster Fuller's geodesic domes. That's why they named them Buckminster Fullerines, or buckyballs for short. It was a startling discovery, an unknown form of one of the best-known substances on the planet, a molecule of 60 atoms with a soccer ball shape that suggests remarkable possibilities.
Another property is this very small ball. It's like a tiny ball bearing, a teensy ball bearing. It's a nano ball bearing. So there's the possibility that one could use this as a lubricant.
Carbon in the form of coal fueled the Industrial Revolution of the 18th and 19th centuries. Today, scientists are developing ways that carbon in the form of buckyballs can create a new industrial revolution for the 21st century.
Well, there's all sorts of implications. Physicists love nothing better than the sphere. And so if there was ever a molecule a physicist would love, this would be it. And I think that virtually all scientists believe that someday that will be the technology that basically is the basis of material science and the important technology for energy, transport, computers, and fields as diverse as medical applications, drug delivery systems, and so forth. It is the ultimate playground on which to build structures. And this buckyball is sort of a calling card to this new area.
Sweet. So what can we do with this nanotechnology? Buckyballs, nanotubes, nanofibers. See any applications there for potential abscission as far as different particles that might try to stick to your piping in your geothermal applications, drilling, heat recovery? metals. Good stuff, huh?